Okay, guys, so the point of the videos and the chapters for the last 2 weeks is to try and go over some actual data analysis challenge. We'll kind of use a few new methods on the way. But this week we're going to be doing a kind of classification challenge, and next week we're going to be doing more of a regression challenge. So this is random acts of pizza, and the idea is on the Reddit site. You basically can say, why you deserve a free pizza. So, some of them are true, some of them are probably not so true. And the idea is that people on the site, if they think you've got a good request, just kind of will actually reward you with a free pizza. And the data set actually gathers a lot of information about these requests, and the prediction purpose is to actually predict whether people are awarded a pizza or not. So it's kind of a fun little thing, but there's applications in social media analytics and social media marketing. So let's kind of go to the R code for this. And this is pizza run.r. And again, we're loading in our helper function that needs to be saved in your directory. And basically, this was downloaded from like the Kaggle website. So I'm just, you can tell from this, we're going to be using some tree techniques. We're going to be using rpart. And it's in a format called JSON. Now, luckily enough, that R actually has a library called JSONLite that allows us to read in JSON data. And we just put from JSON, pizza.json, flatten equals true. And let's just have a look what we've got inside our pizza data set. So let's just have a look at str pizza. And we've got a lot of information. So we have the number of votes for the request, so how popular the request was. So that's obviously, if people like the request and upvote it, then it's more liable to get a pizza. The number of comments you got on your kind of thread, the actual request of the kind of text. So this is like 4 children, spend my last money on gas today, broke, cold, hungry, etc. So these are kind of all the requests. Then we actually have some information about the requester, how old they are, how many comments they've made. So this is kind of measures of how socially engaged they are with Yelp. So how many comments they've made in random acts of pizza, number of posts on random acts of pizza, and the number of subreddits. These are just like if it's got a Reddit, it can have a subreddit. And then finally, we have the dependent variable, which is whether they request to receive pizza or not. So we can actually also just look at the data set. So let's have a look at this. Let's just view it. And here we go. And you can see we have some of this information is numerical and some of it's actual textual. So we've got the request text. I think it's edited request text, the title of the request. And then we have all that information about, the requesters' posting habits and their account, etc., etc. And here we have whether or not we receive the pizza or not, which is our dependent variable. Okay, so let's kind of go back to our pizza run. We'll just have a look at the size of the data set. So where are we? Just use dim to tell us the size of the pizza data set. And it's decent. We've got 4,000. We've basically got 4,000 rows and 30 columns. And we want to check if there's any missing data. This is just is.na. You've used it before. And just count the sum for each of the columns. and most of the columns have absolutely no missing data, which is actually nice. But we have request user flare that does have some missing data. Now let's just have a look at request user flare. And this is like the users can have kind of flair on their website, on their kind of profile. Now here, most people have shroom, which I think must be short for mushroom. And somebody has a PIF. I have no idea. That person must want to be individual in this crowd full of shroom. So here we have another PIF. Now, obviously, this is textual data at the moment. It's not very good. And we only have a few PIFs. So let's just change this and say we'll have, true if they have flare and false if they don't have flare. So we're going to change this. Request to user flare is basically, we say is .na. So that's if it's missing or not. Not if not NA. So basically if it's a present, it's true. And if it's not present, it's false. And we just kind of convert that to 1 and 0 numbers. And let's just have a look at that column again. And you see it's all 1s and 0s. So if they had a flare, whether it was shroom or PIF, then they'd have a 1. Otherwise, they'd have 0. Okay, so let's just have a look at a few other things. We've already viewed the pizza. And let's just have a look at the pizza post was edited. And again, this is kind of similar. We've got I think it's a bit inconsistent this. We've got 1 if it's been edited, but some of them actually have some sort of edit date in, which really is not in a format that we can use. So again, we're just going to say if we've got a date, it means it's been edited. So we're going to change it to 1 to be edited. So let's just now have a look at pizza was edited. And again, 1 and 0. So this is what we're doing. We're doing what's called data cleaning here. We're basically getting rid of any information or trying to summarize any information that's going to be very hard to predict or build models with. Okay, so what we're going to do now is we're basically going to take the non-text column. So we define our columns. And we create a new data set pizza2 that basically has these columns. And you notice the last one, column 23, that was actually the dependent variable. I remember I said my little class eval likes this to be called y. So we're going to call this y, and we're basically making it the last column. So let's do that. And here we have the new pizza, and it's basically all the numerical data. And then last we have the dependent variable. And let's make this dependent variable, it's currently a Boolean, let's just make it a factor, which makes it easier for some techniques. So whether they ordered a pizza, true or false, with level variable with false and true. Now let's just see which variables could actually be useful. So we can use the aggregate as we used before, and basically all the variables except y, we're going to split by y and we're going to do the mean function. And then we can see, and this doesn't account this doesn't account for the standard deviation in the variables, but we can kind of get an idea of number of upvotes For a request that was not received. For a request that was given was 8, and a request wasn't given was 5. Now, funnily enough, the downvotes are very, very similar. It could be that, you know, some requests got a lot of attention, whether positive or negative, and it's actually the ratio more important than the actual up or down votes. Post was edited. Number of comments, again, one getting more attention is more likely to be rewarded. Older people get slightly more likely to be rewarded. And this is actually really important. This is the number of days since the first post. And generally people who have, and maybe this is just people who like posted a few days ago and are spamming the forum with lots of requests and just getting no's, and people who maybe make a request once every, say, 6 months when they're, you know, they're in a little bit of difficulty, are more likely to get the request. Okay, and again, users who are more engaged, more part of the community, are much more likely to get their request fulfilled. Okay, so as I said, you know, this is really simple, but it actually gives them some insight into, you know, what's useful. Okay, let's just draw a few box plots. And here we're going to do basic, just exactly as we're doing in like the first few weeks. So the number of comments for a pizza awarded. Or not awarded. And what's happened here? Well, nearly the majority of requests have 0 comments. So we get, you know, this really kind of flat, from the 25% to the 70%, it's really flat. And then all these outliers. But we can do better than this. We're going to actually do a log. But we have to do a log plus 1, because log of 0 would actually break it. And here we go. So you could have, these are like the number of votes for the pizza awarded, and you see a true, you know, there's much less standard deviation. Some of the ones not awarded have a lot of votes, but there's a lot of them with only a few votes. Okay, so let's do some of the, now let's go do some of the stuff that we did in chapter 4. Or week 3. So let's do the principal components analysis. So all this numerical data, we just take the principal components analysis. We're going to use the fact extra to get the eigenvalues. And let's just have a look. It's not brilliant, you know, we get, because we have a lot of data dimensions, but we get about nearly 40% of the data in the first 2 dimensions. Now let's look at our loadings. And we have 2 principal components. And you can see this first one's quite high on number of comments and number of posts and, you know, up and down behavior. So this is kind of almost a measure of somebody's, you know, engagement in the site, and or just number of engagement in Reddit in general. And this one's quite high in specific for, you know, the random acts of pizza. So you can almost think dimension 1 is just general Reddit engagement, and dimension 2 is more random acts of pizza engagement. And we're going to actually do the same. We're going to do as we did in chapter 3. We're going to do the varimax rotation. And again, this is just trying to make the loadings as close to 1 or 0 as possible. Okay, now let's just have do what we did in chapter 3 and actually put our solution. And what we're going to do is we're going to color them whether they're red or whether they are, if they were ordered the pizza, and blue if they weren't awarded the pizza. So the same code we've used before. And you can see there is some separation there. you can see that these people down here, the ones who are very low on 2, which is the random acts of pizza engagement, are unlikely to get a pizza. And these people who are high on engagement up here are much more likely to get a pizza. Doesn't seem to work quite as well for the general engagement as it is for the actual random acts of pizza engagement. Now, let's just see what insight we can get from having kind of logistic regression, see what's important. And you look here, let's just see what's important. Number of downvotes. That's actually kind of negative. And you remember that this is, in logistic regression, a negative value means you're less likely to choose the true category, which in this case is being ordered a pizza. So number of downvotes, you're less likely to be awarded a pizza. If your post was edited, you're more likely to be awarded a pizza. I guess it means you've thought a little bit more about it. The number of comments on the request, how much attention it gets, much more likely to be awarded, which I guess it would keep the thread high up in Reddit, and it would be likely to be more, somebody who had money to give a pizza was more likely to give it attention. And number of comments the post has made in random acts of pizza. And interestingly, comments is kind of positive, but posts at the request is negative. So again, I think this is some people just go on this and ask for pizzas every week, and this is just not going to fly. And then we have a few minor significances, for example, the downvotes. Now, you can actually check variance inflation factors for logistic regression as well as regression. And we actually here get the variance inflation factors. And look what happens here. Account age in days at request, account age in days at retrieval. You know, this is you make a request and you retrieve it later, and it might be 30 days later. So it might be like, you know, this plus 30. So these guys are very kind of heavily related. These aren't the actual values. These are like the variance inflation factors, but you can see why these guys are pretty much the same thing. And again, days since first post is liable to be very similar to the account age. So again, these three variables are probably a little bit problematic. And let's just check the GG Galley code. And let's just remind myself which columns we're trying. Well, this takes a minute. Okay, so you see here, these are the age variables, the counted, the two age variables. Look, they look pretty much, they're in a band, but they're incredibly highly correlated with one another. And some of these guys, like days since first post, you can tell that some of these variables are obviously suffering from multicollinearity. So we have to be a little bit careful there. So let's try, as a final thing on this first video, let's just try a little bit of linear discriminant analysis. And let's just have a look here. And you see this is almost, you know, the class means for true and false. You see the majority, about a quarter of the requests got pizzas. And then we have, for example, the means for the false and the true. This is actually what we did before, but this is reported as part of linear discriminant analysis. Remember, linear discriminant analysis tries to fit a line between these group means. And this is like the equation of that line. So number of downvotes is negative, upvotes is negative, post was edited is positive. Okay, so we've talked about the data set, we've loaded it in. We've performed a little bit of basic data analysis. In the second video, we will go on and perform tree techniques. We'll do some prediction using cross-validation, and then we'll do a little bit of textual analysis, see if we can improve the model with textual analysis.